Welcome to Water Bounds of River Basins. My name is Andreas de Jong. In today's video, I'm going to show you how to make reservoir elevation area capacity curves in QGIS. We're going to be looking at the Mirani Reservoir. It's located in Balochistan, Pakistan. We'll extract the contours from the digital elevation model and use them to create a polygon of the maximum flooded areas. We'll deal with some problems in the polygon like these holes, and then we're going to use it as a cookie cutter to extract the DEM of the flooded area. Finally, we're going to use a special Python script to automatically extract all the data we need to create these elevation area capacity curves of the Mirani Reservoir. I hope you enjoy it. We're going to be using QGIS 3.4 Bratislava. Let's get started. The first thing which we need to do is to set up the GIS. This is the catchment area of the Mirani Reservoir, which we developed in our previous video. Today what we're going to do is work on the reservoir area itself and use a digital elevation model to calculate the elevation area storage capacity curves. So what we need to do is cut out a piece of the DEM which covers the maximum flooded area and a bit beyond. So let's go to raster extraction, clip raster by extent. Under clipping extent, let's choose the current map extent and press run. So it looks a bit dark. Let's copy the stars across. So notice this is a temporary raster DEM. The next thing which we need to do is to create contours from the SRTM. Select the clipped raster, go to raster extraction contour. We're going to need an interval of, let's say, 5 meters. Press run. Let's zoom in on our dam area. Okay, our contours are ready, but they're a bit difficult to see. I'm just going to change the style. Double click style, load style, press the 3 buttons, load the contour style, press apply and OK. Okay, select the contours, press on identify features. And our dam is probably around 80, maybe 75 meters SRTM elevation. So let's take a contour line that's at least 10 or 20 meters above that. And I think I'm going to go for 95 meters. Press the select features button, select the 95 meter contour, go to edit, copy features, edit, paste features as a temporary scratch layer. We'll call it 95M. Okay, so we have a contour line that goes right around our reservoir area, which is nice. The next thing is to delineate the maximum flooded area. Let's zoom in on our dam area and let's make our contour line a bit darker and thicker so it's easier to see. Basically what we want to do is to chop away the parts of the contour line which are downstream of our reservoir. For that we're going to need another toolbar, which is the advanced digitizing toolbar. And I think we might as well also switch on our snapping toolbar. But we don't want to snap at this stage. So what we want to do is to chop our contour line around the dam axis. Let's start by editing it. Select the contour line and select this tool here, the split features tool. Click on it. Now I think I want to cut this line about here, so left click, left click, left click, left click, left click, go outside and right click. So you see that the colors have changed. Now the black contour line is no longer selected, which means it's been chopped at this and this location. Right click, open attribute toolbar, and what we're going to do is switch the selection and delete the 2 features and stop editing. Okay, so we now have a contour line that goes right around our reservoir and it's been cut off close to the dam axis. The next thing which we want to do is to join it up so we can turn it into a polygon. Start editing, click on the add line features, Make sure that snapping is enabled by clicking on the red magnet. Now as you approach the end of this polyline, it'll show a little pink square. Click left, left click, left click, left click, go along the dam axis, go to the end of this polyline, left click, go outside and right click. The fit, let's give it a number like 100, and the elevation is 95 meters. Press OK. Stop editing, save, zoom to layer. Okay, we've made a polyline that goes right around our flooded area, including the dam axis. But if we have a look inside, you can see that it's still made out of two separate polylines. So what we need to do now is to merge them. Go to Vector Geoprocessing Tools and hit Dissolve. Press Run, close. Open the attribute table and you see we only have one polyline now, which goes right around our reservoir. Let's just copy the stars across. The next thing which we're going to do is to convert our polyline into a polygon. Select the dissolved temporary polyline, go to Vector, Geometry Tools, Lines to Polygons. Press Run. Let's zoom in on this area here, and you'll see that there's some weird shapes here. This is called a bow tie or a figure of 8, and these little things here are called slivers or spikes, and that's not good for later processing. So what we're going to do is fix these intersecting geometries. Go to Vector, Geoprocessing Tools, and look for Buffer. Now we're going to have a distance here of 1 meter, and the cap style will be flat and the joint style will be a miter. Press Run, close. If you look, the slivers have disappeared. Now the next thing what we're going to do is to correct this polygon, because obviously it's become a bit bigger than before. Go to Vector, Geoprocessing Tools, Buffer, and instead of +1 we're going to put in a -1. Again, make it flat and miter and press Run. So now if we have a look at before and after, we have the same polygons but without the slivers. Now we still have holes in our polygon, which is not good. So let's go and fill the holes. Go to the processing toolbox and search for delete holes and just press Run. Close layers. You can see how our polygon has been completely cleaned up. It has no more holes and no more weird artifacts. Zoom to layer. So I think what we're going to do now is to save it. Right click, export, save features as, put it in a geo package called Mirani, and I think we're going to call it. Okay, there's a green sign here saying that it has exported correctly. Another thing I want to do is to export the same feature, but we're going to export it in WGS84 geographic coordinates. Press OK. We're going to delete all of our temporary vector lines. And I'm also going to save this DEM. And I think what we'll do is copy the styles across as well. Now delete the raster layer. The next thing which we're going to do is to clip the DEM to the maximum flooded area. So select the digital elevation model, go to raster extraction, clip raster by mask layer. Our mask layer is of course our polygon of the reservoir, and you can leave everything as it is except this one here. Assign a specified node data value, and for that we need to pick a number that does not occur in our raster, so let's use 99999. If you forget to do this, what will happen is that outside of the reservoir area you're going to have a whole bunch of cells with 0 elevations, which is not good. Anyway, press Run and close. Now we have a digital elevation model of the maximum flooded area. So what we can do now is to export it. Right click, export, save features as. We leave it in the projected coordinates and press OK. Let's get rid of the temporary layer. Let's also change the color here. Go to symbology, single band pseudo color, and we're going to use turbo. Press classify and OK. I think we're going to use quantile. Might be look a bit better. Here we go. The next step is to calculate the elevation area capacity data from the DEM using some Python code. So we've got our Mirani Reservoir DEM selected. Go to Plugins Python console, or else you can open it using this icon here. Click on the notebook, which is to show the editor. Open the script by clicking on the first button here on the right. Select the reservoir stage calculator, press open, and all you need to do is click the run script icon. If you've already chosen the reservoir DEM, it'll be already selected. If not, you can look for it in the drop-down list. Press OK. It's going to automatically suggest the minimum elevation from the DEM. I think we can use 47 meters. It's also then going to give you the maximum elevation from the DEM, but that's probably a bit high because that'll be the top of these islands here. We're going to use our maximum of 95 meters. Press OK. The increment, which means how often do you want to calculate the data, is every meter. It's OK. Press OK. OK, so we have a temporary table here. Let's open the attribute table, and you can see that from 47 all the way up to 95 meters, we have the pixels, the area, the capacity, the area in hectares, square kilometers, the capacity in million cubic meters, acres, and also acre feet. So the next thing which we need to do is to export the table in Excel format. Just look down for MS Office Open XML Sheet and click on the three buttons. I'm going to put it in the Excel directory and I'm going to call it. Press save and OK. Now you'll see it's loaded it again. You can check if the data is still there. Yes, it is. That's good. We can close down our Python console. We can get rid of our temporary layers. And that's the end of the processing in QGIS. So now we're going to be working in Excel. First of all, we're going to import the data we just calculated in QGIS. This is a copy of the Excel template. Please follow the instructions in the green boxes. Do not touch the yellow boxes because they're full of formulas which do things automatically. First of all, let's add the name of the reservoir. And you can also add other information which you find useful for the interpretation. Let's go to data, and we're going to be adding the data from the QGIS file. So it goes from elevation up to capacity. Don't touch the yellow areas. Here it goes from base level to capacity. Select all the data, Ctrl C to copy, and go into the first cell here under elevation, Ctrl V to paste. The data should paste all the way down and all the yellow boxes should be filled correctly. And you can also see the different curves and you can see if the data is in good shape or not. The next step is to adjust the elevation area capacity curves. Click on Reservoir Curves. Here is the chart of the reservoir curves, and we're going to have to adjust the axis a little bit. So the capacity curve goes from 0 to 4,000, but actually data stops at 3,500. So let's change that to 3,500. The intervals is every 500 million cubic meters, which is not bad. If you look at the top here, the area numbers don't line up with these vertical grid lines. So let's change that to 40 kilometers. And now it's not bad. Down here we have the estimated top of spillway. We're going to work on that in a while. First of all, let's adjust the elevation on the y-axis. So we don't want it to start at 0. Let's put a minimum of 40. And we're also going to have to do that on the other side. because we actually have a primary and a secondary axis, so the area is on the secondary axis. Okay, let's add the spillway. Let's go to Info. Remember, this maximum here is 3,500. Go to Info, and we're going to replace the formula here with 3,500, and also put an estimate of the top of the spillway. I think it's 76 meters, but that's something we can confirm later on when we have the monitoring data. Okay, so here are the elevation, area, capacity curves, and if you have a look here, top of the spillway, it looks like that gives us a capacity of something like 400 and something million cubic meters, and an area here of probably around 60 square kilometers. In the next video, I'm going to show you how to download free satellite-derived monitoring data of the reservoir surface area, and we're going to be using that data to see how the capacity as well as the water levels of the Mirani Reservoir have changed since 2007. Hope to meet you there.